Good evening, students. Today I will discuss some questions related to motion in a straight line. Okay, see the first question here. The position of an object moving along x-axis is given by x equal to a plus b t square, where a value is given 8.5 meter and b value is given 2.5 meter per second square, and t is measured in seconds. Its velocity at t equal to 2 seconds and the average velocity between t equal to 2 seconds and 4 seconds. So this is the question given, and the important information given here is the equation. Equation is related to, here the equation gives the relation between position x and time t. What is the relation given? X is equal to a plus b t square. And of course, a value is given, b value is also given. Later on, we can substitute the a and b values also. And the first question here is, from this information, you have to calculate the velocity of that particular body at t equal to 2 seconds. That is the first question. The first question given is velocity you have to calculate at 2 seconds. But information is given for position only, na? And how can you write the relation between this position and velocity? Velocity is nothing but change in position by change in time. That also can be taken as velocity equal to dx by dt. Simply it is the differentiation for the given equation. So what is the derivative for some constant value a? It is 0 only, plus derivative for bt square will be, we all know that that is simply 2bt. And what is the value of b given here? B value is given 2.5, and time, at what time they're asking us to calculate velocity? At 2 seconds. And finally here the answer will be 2 into 2.55, 5 into 2, 10. And of course this is velocity only, na? So this is 10 meter per second. That is the answer for the first part of the question. In the question it is given that the relation between position and time, and at one particular time they're asking us to calculate velocity. Just by taking the differentiation you will get the answer here. And what is the second question given? Average velocity between 2 seconds and 4 seconds. Average velocity means it is nothing but total displacement by total time. Generally velocity means displacement by time, and average velocity in the sense total displacement by total time you have to write. See, first you try to calculate the initial position. To calculate the displacement is nothing but final position minus initial position. Initial position, for position we have the equation. Initial position means from 2 seconds you have to take. At t equal to 2, you have to write this value, x equal to a plus b into 2 square. How much it will be? A plus 2 square will be 4b. And what is the final position? Final position means it is given here at 4 seconds. So you can just substitute 4 for x only, 4 for time only. So that will be a plus 16b. And what is the time gap between them? Change in time is 2 seconds only. So now we can write here that V average is equal to displacement, that means x final minus x initial, by total time, change in time, t initial. What is the final position minus initial position? A plus 16b minus a plus 4b. That will be a and a will get cancelled. That will be 12b, by difference in time will be 2, and finally it will be 6b. And of course, what is the value given for b in the question? For b it is given 2.5 meter per second square, na? So that we can write here 6 into 2.5. That will be 15. This is the 15 meter per second. Okay, that is the solution for this particular question. Now, next one. All of you just read the question. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. The height to which the ball rises from the ground and the time taken before the ball hits the ground are. This is based on just very simple formula. Okay, so first of all, you try to draw here the given information. So that is, a ball is thrown with 20 meters per second velocity from top of the building. So if I consider, let me consider this is a building from which, and of course, the height of the building is also given. How much is given the height of building? That is 25 meters only. And when any particle is projected here, with what velocity it was projected? 20 meters per second. And the first question is very simple, that the height to which the ball rises from the ground. So when any particle is projected with velocity 20 meters per second from a certain point, what is the maximum height it can reach? So the general formula for height will be h equal to u square by 2z. Very much familiar formula. What is u square? Initial velocity is given 20, na? 20 whole square by 2 into 10. How much this will be then? 20 square will be 400 by 20. That will be finally 20 meters. What is the maximum height it can reach from the projected point? 20 meters. But the question is, the height of the point from where the ball is thrown is 25 meters from the ground. Okay, the height to which the ball rises from the ground. From ground, you have to take the height to the highest position. So that from here to here, we just calculated that it is 20 meter. From ground, it will be 25 plus 20. So the answer for this particular factor is from ground. It is 45 meters. That is the answer for the first question. And what about the second question? And the time taken before the ball hits the ground. And from this point, when you project a body, let me consider it is going to certain height, and again if it reaches the ground, if this is the upward path and this is the downward path, the total time how much it takes you have to calculate. If any particle is projected from top of the building, we have a simple formula, that h equal to minus ut plus half gt square. Height means height of the building only. Height of the building is 25 minus initial velocity given here is 20 meters per second. Time you have to find out, plus half into g can be taken 10 here, na? So half into 10 will be 5. So this will be 5t square. And if you just divide the whole equation with 5, then this will be 5 equal to minus 4t plus t square. And simply you can write t square minus 4t minus 5 equal to 0. Okay, this can be taken as t minus 5 into t plus 1. Na? You can just write this equation as, this quadratic equation as t minus 5 into t plus 1. Then what is the time? T equal to 5 or minus 1, but time will never become negative, na? So the answer is only t equal to 5 seconds. Okay. Now, what is the condition here? It was given here that the particle was projected from top of the tower. In such cases, always we have to use the formula h equal to minus ut plus half gt square to calculate the total time of flight from here to reach the ground. So where h is height of the tower only, where h is height of the tower, u means initial velocity given, the time means the total time of flight in this particular case. Okay. Now, question number 3. The distances traversed during equal intervals of time by a body falling from rest stand to one another in the same ratio is. So when any particle is dropped, start falling from rest in the sense, we can say that the particle is dropped only. When any particular particle is dropped from certain height, the question is the distances traveled during equal time intervals. That means in first second, how much it travels. In second second, how much distance it travels. In third second, in each case, I am taking 1 second only. Na? In 1 second, if you want to calculate in one particular second or in nth second, if you want to just calculate the distance traveled, there is a simple formula that S equal to U plus A by 2 into 2n minus 1. And of course, here the ball is falling from rest only. Na? That means U becomes 0. So Sn of A is acceleration. Acceleration due to gravity is constant. So Sn is proportional to 2n minus 1. If you want to calculate S1 is 2, S2, S3, so on, if you want to calculate, then everywhere you can substitute 1, 2, 3 for n. If you substitute 1 for n, 2 into 1 minus 1 will be 1. If you substitute 2, 2 into 2, 4 minus 1, 3, 2 into 3, 6 minus 1, 5. Like that, you will get the answers. This is the ratio. This is the ratio of distances traveled in equal intervals of time. That means in first second, second second, third second, like that. Okay. See the fourth question. Two parallel rail tracks run north-south. Let me consider here. There is a rail track here from north to south or south to north. Let me consider this is the north direction and this is the south direction for my convenience. I can consider in any way. And train A moves north with a speed of 54 km per hour. The speed of train A is given. Velocity of A is given. What is that? 54 kmph. In which direction? 54 kmph moves north, towards north. Let me consider north direction is represented as j cap and south is represented as minus j cap, for example. So then what is VA bar? Then VA bar can be taken as 54 j cap. And train B moves south with a speed of 90 kmph. The speed of train B, VB bar, can be taken as 90 and towards south only. Na? I can take here minus j cap from my consideration. Where I have taken j cap is the symbol for north only, direction for north only. Now, the velocity of a monkey running on the roof of a train A against its motion, in whatever the direction train A is moving, for that particular, a monkey is running against the train's motion. In that particular case, one information is also given here with a velocity 18 km per hour with respect to train A. That means the monkey's velocity with respect to train A is given here. What is that? 18 km per hour. Okay. Now see here, velocity of monkey with respect to A. We know the general formula. Na? What is that? Velocity of A with respect to B is VA bar minus VB bar. In the same way, velocity of monkey with respect to A is VM bar minus VA bar. Now, what is VMA bar is given? That is given 18 km per hour. It is given 18 km per hour, and how it is moving? Running on the roof against its motion. The train A's motion was taken in the direction of north. That means j cap. And this will be minus j cap. This is equal to velocity of monkey that we don't know minus velocity of train A, that is 54 j cap. And now you see here, what is velocity of monkey then? Velocity of monkey can be calculated 54 j cap minus 18 j cap. What is 54 minus 18? It is simply 36 j cap. And finally, the velocity of monkey, original velocity of monkey is 36 j cap. And what is the question here? From the information given in the question, just we calculated the real velocity of monkey. But the question is, as observed by a man, the velocity of monkey, we have to calculate velocity of monkey as observed by a man traveling in train B. That means with respect to B, with respect to train B, you have to calculate velocity of monkey. That means you have to calculate here velocity of monkey with respect to B only. What is that? Simply Vm bar minus Vb bar. What is Vm bar? Velocity of monkey, just we got the answer, that is 36 j cap minus, what is the velocity of B bar taken? It is minus 90, na? This is minus 90 j cap. Totally 36 j cap minus into minus plus 90 j cap. 36 plus 90 will be 126 j cap. That is 126 kilometer per hour. But the options were given in terms of meter per second. So how can you convert kilometer per hour into meter per second? That is nothing but if it is in kilometer per hour. So 126 into, to convert it into meter per second, you have to multiply with 5 by 18. So 18, 7 ja, it will be 7 5 are 35. And finally the answer is 35 meter per second. We just got the positive value, na? Positive value in the sense it is this VMB bar is just towards north. Okay, see, again I will show you the question here. Very much important model question it is. If two trains are given which are moving in opposite directions, one towards north and other towards south, so that we have given just north was taken j cap and south was taken minus 90 j cap, and the velocity of monkey which is moving against the motion of A, and whose relative velocity with respect to A is 18. So based on that, you have to calculate velocity of monkey with respect to train B only. So that first way I calculated from the basic relative velocity formula, that is VMA bar equal to VM bar minus VA bar. By substituting in that, just I calculated VM bar equal to 36 j cap, and then VMB bar will be 35 meter per second I got in terms of meter per second. Okay, now question number 5. A particle in rectilinear motion is at origin at time t equal to 0. Velocity of the particle related to distance traveled by the particle as v given 5x plus 2, velocity and distance relation. Okay, now displacement of particle in time t is, and x equation only they are asking in terms of time. Velocity equation was given in terms of displacement, but they are asking displacement equation in terms of time. So just the same equation you can take here. What we can write for velocity? Velocity is always equal to dx by dt, which is equal to 5x plus 2 given. But to calculate x value only, all the x values you can just bring on one side. That is dx by 5x plus 2 is equal to dt. By taking integration on both sides. Of course, integration is from 0 to x and time is from 0 to t. because you have to calculate x value from dx only, na? So that we have taken here integration. Now, what is integration for dx by 5x plus 2? That is log of 5x plus 2 from 0 to x, and integral dt will be t, and of course it is also from 0 to t. Now, if you substitute upper and lower limits here, when you substitute x here, you will have only log of 5x plus 2. But when you substitute the lower limit 0 here, 5 into 0 will be 0. Okay, and of course here the logarithm will be 1 by, for 1 by 5x plus 2 integration is log of 5x plus 2 and by 5. The derivative of inner function also I have to consider. So I can take here 1 by 5. When you substitute the upper limit, that is log 5x plus 2, when you substitute the lower limit 0 here, 5 into 0 will be 0, only 2 will be there. That means it will be log 2, and which is equal to, by substituting upper and lower limits here, you will just get only time t. Now, this will be log of 5x plus 2 minus log 2. This is equal to what we can write here, 5t. And finally, you have to write an equation for x only, na? So that I can just take here log a minus log b can be taken as log a by b. That is log 5x plus 2 by 2 is equal to 5t. But you have to get the relation for x only, na? So logarithm should be cancelled. What is the opposite function for logarithm? Exponential function. If you apply the exponential function, you will get 5x plus 2 by 2 is equal to e power 5t. And then, so 5x will be equal to 2e power 5t. And finally, 5x is equal to 2e power 5t minus 2. And finally, x is equal to 2 can be taken common here. 2 by 5 into e power 5t minus 1. This is the final relation between x and time. So this completely depends on simple integration method only. Okay, we should not confuse with all these simple integrations. Just the question is very much simple. Velocity is given in next one. Question number 6. A particle is dropped vertically from a height 20 meters above the ground. It hits the ground and bounces up vertically to a height 10 meters. Neglect the subsequent motion and air resistance. Take upward direction as positive. Velocity versus time graph is. See, very much important model question it is. From the information given, height was given, after rebouncing the height was given, and based on that, you have to draw here a graph between velocity versus time. Okay, now what is initial? Initially it is dropping from 20 meters height only, na? So that first of all, here I will just indicate an x and y axis. And here I can take velocity on y-axis, time on x-axis. Of course, initially the time is 0. The particle starts from origin only. And we know that the particle is just dropped from 20 meters height. That means what is initial velocity? 0 only, na? Initially time is 0. Initially velocity is 0. But the upward motion is to be taken positive. Velocity is to be taken positive for upward motion. But when you just drop the body from certain height, in downward direction the body moves, so that you have to take that velocity is on negative side. And we know that uh, when a simply body is dropped, v equal to u plus at, and of course initial velocity u 0 na, so that v equal to at. And well, for freely falling body, acceleration remains constant only na, so velocity proportional to time, so that we know that it is simply a straight line. It is simply a straight line. But when it just reaches the ground, what will be the final velocity that we have to calculate? When any particle is dropped from 20 meters height, what will be the final velocity? V is equal to root over 2gh only. Na? Simply you can write here V equal to root over 2gh, and that is equal to root over 2 into 10 into height is 20. Na? So this will be 20 into 20. So square root of 20 into 20 will be 20. And final velocity when it reaches the ground will be 20 meter per second. So here you can represent, this indicates 20 meter per second, and of course negative side only. Na? So minus 20 meter per second. And what is the time taken here? What is the time taken to reach ground from 20 meters height? That is simply t equal to what we can write, and time you can calculate by using t equal to v by z. What is velocity? Final velocity is 20 na, g is 10 only na. 20 by 10 will be 2 seconds. That means whatever the point on time it covers, that is 2 seconds. And later on, one more information is also given in the question. You can see here again what is happening. Again it bounces up vertically to a height of 10 meters. That means from this particular velocity, whatever the velocity it reaches, with what velocity it reaches the ground, with same velocity, if it bounces back, it can reach up to 20 meters. But it is given that it can reach up to 10 meters only. That means some of its energy is lost here. Only with some amount of energy, remaining energy, it is going up. What is the height? It can reach 10 meters. Then what will be the velocity? With what velocity it is moving up? That you have to calculate. Now, while it is bouncing back, again you can use the same formula, V equal to root over 2gh, or U equal to root over 2gh, root over 2 into 10 into 10. That is root 200, which is equal to 10 root 2. That means again it starts moving in upward direction with velocity of 10 root 2 meter per second. And while it is moving, it has to be taken as positive side. So that here you can consider it is 10 root 2 meter per second. After 2 seconds, it starts from this particular point. While it is moving in upward direction, what will happen to its velocity? Velocity decreases only, na? And of course, uniformly velocity decreases in such a way. And finally, this particular particle reaches the zero velocity. At maximum height, again, it can reach the zero velocity. And of course, you have to calculate what is the time taken in upward motion. In upward motion, the time taken will be t equal to u by z. And u I calculated 10 root 2 by g means 10. That means how much time it takes to reach the maximum height. That is root 2 seconds only. Na? And this is 2, and the remaining part is root 2. Root 2 means it is 1.414 seconds. 2 seconds plus 1.414. Totally how much it will be? 3.414 seconds. Okay. In such a way, just you can draw the graph here. And of course, here the direction changes. This is the everywhere you have to represent the time values in both the cases, and also velocity values in both the cases. With what velocity it reaches the ground, and with what velocity it bounces back, both can be represented here. Okay. Next, question number 7. Two trains A and B of length 400 meters each are moving on the two parallel tracks with a uniform speed of 72 kmph in the same direction with A ahead of B. So two trains were taken where both the trains are having the velocities 72 kmph only, and A is ahead of B given, and the driver of B decides to overtake A and accelerates by 1 meter per second square. And if B wants to overtake A here, then definitely he has to increase his velocity. Na? How he increased his velocity? By having an acceleration of 1 meter per second square. If after 50 seconds, the guard of B just brushes past the driver of A, what was the original distance between them? So after 15 seconds, he just crossed A only. Then in that particular case, they're asking us to calculate what was the original distance between them. You just try to calculate that. And you see here, what was the initial relative velocity? We don't know at what distance initially they are. Initial separation, yes, relative. Separation at initial position, that we don't know, that you have to calculate. Let me consider it is x only. And what is the initial relative velocity? U relative. Initially both are having same velocities and same direction only, na? Then relative velocity, velocity of A with respect to B or velocity of B with respect to A, both will be 0. And what is the acceleration of B with respect to A? Acceleration of B with respect to A, if you want to calculate, acceleration of B minus acceleration of A, and acceleration is there only for B, not for A. So for A acceleration is 0, for B acceleration is 1. So relative acceleration will be 1 meter per second square. And finally you have to calculate S value only, na? And it is given the time taken will be 50 seconds. And here the time taken will be 50 seconds. Now, which formula we can use here? Simply we can use SC equal to UT plus half AT square. S value, that relative distance only you have to calculate, and of course U relative is equal to 0. So the first factor becomes 0, and here half relative acceleration is 1 and T will be 50. 50 square. 50 square will be 2500. By 2 it will be 1250 meters. How much distance the P traveled, how much distance B traveled is 1250 meters only. Okay, but see here, if two trains are like this, for example, if this is train A and if this is train B, and of course both are having the length of 400 meters each, and this if this is the initial separation, and finally they have given that the guard of B just brushes past the driver of A, guard of B, the back part of B overcomes the front part of A. That means not only the distance x, along with this distance, which was also covered here, the length of B and length of A were also covered there. Na? That means 1250 includes the separation plus length of A and length of B. Whole thing will be covered there. Length of A plus length of B will be 400 meters only, na? Because each one is having the length 400. So total length will be 800. So 1250 minus 800, how much it will be? 450 meters. That 450 meters is the initial separation between guard of A to the driver of B. the separation will be 450 meters. Okay. Thank you.